Welcome to America Reads Fun Learning Activities. We're college students who create learning activities for kids. Our fun activities are focused on reading, writing, and math. Thank you so much for joining us to learn today. Today's video is about square and cube roots. We will be solving some problems together and then discussing why and how the square root of 2 is irrational. A square root is the number that, when multiplied by itself, equals the variable n if n was a positive number. A cube root is a number, when multiplied by itself 3 times, equals the variable n if n was a positive or negative number. We will also need to know what is and how to use the radical symbol. When this symbol is around a number or numbers, it tells us to find the square root. If there is a 3 in the small space in front of the radical symbol, that means find the cube root of the number or numbers inside of it. To start our look into this topic, let's solve some problems by using the radical symbol to find the variable x. To solve these problems, we do not need to know the exact number that x represents, just what it is in radical form. Let's start with finding the answer for x squared equals 4. To solve this, we need to do the inverse of the second power, which is the radical symbol. The answer to this problem would be the square root of 4. Now let's find the answer to x squared equals 9. Again, we use the inverse of the second power to solve for x. This means the answer is the square root of 9. Now try x squared equals 49 on your own. Let's see how you did. The answer is x equals the square root of 49. To solve problems like this, but to the third power, is extremely similar. Just remember that the inverse of taking a number to the third power is the cube root. Let's solve x to the third power equals 8. Remember, we do the inverse, so x is equal to the cube root of 8. Now let's solve x to the third power equals 27, and the answer would be x equals the cube root of 27. Now try x to the third power equals 82 on your own. Let's see how you did. The answer is x equals the cube root of 82. Now let's try some problems where we want to actually know the square and cube roots. Not all numbers are perfect squares or cubes. This means that not all numbers have whole numbers that are multiplied by themselves to equal them, but some do. And let's take a look at those. Let's solve the square root of 9. This means we need to find whatever number multiplied by itself is equal to 9. That means we need to look at the factors of 9. We could use a factor tree or sing our times tables, and however you feel comfortable with finding them is fine, but I'm just going to list them out. There is 1 times 9 and 3 times 3. As we can see, 3 times itself is 9, and that means the square root of 9 equals to 3. Now we'll solve the square root of 4. Again, we're finding what number times itself is equal to 4. And again, we're going to list the factors. The factors are 1 times 4 and 2 times 2. That means that the square root of 4 is equal to 2. Now that we've solved some together, why don't you try the square root of 16 on your own? Let's see how you did. The answer would be 4. Now let's do the same thing but with cube roots. Let's solve the cube root of 8 together. For this, we need to know what number multiplied by itself 3 times is equal to 8. We can use its factors to find this number too. We know that there is 1 times 8 and 2 times 4, and we have to break down these numbers till we get 3 of the same number. We already know that 4 is 2 times 2, so 2 times 4 is basically saying 2 times 2 times 2. That means the cube root of 8 is equal to 2. Now let's solve the cube root of 27. And again, we're going to look at the factors of 27. There is 1 times 27 and 3 times 9. We need to break these numbers down more to get the same number times itself 3 times. We know that 9 is equal to 3 times 3, so 3 times 9 is actually 3 times 3 times 3. So the cube root of 27 equals 3. Now that we've solved some together, why don't you try the cube root of 125 on your own? Let's see how you did. The answer is 5. Those are examples of perfect cubes and squares. Now, I want to show you an example of a number that does not have a perfect square root, and that the square root is irrational. This is the square root of 2. It is an irrational number meaning that it is a number that cannot be expressed as a ratio of two integers. I'm going to explain this concept by creating a proof. A proof is pretty much just a math argument. It shows that the stated assumptions logically equals the conclusion. To start our proof, we have to assume the opposite of what is true. We have to assume that the square root of 2 is a rational number. And because the square root of 2 is a rational number, there is a fraction of the variable a over the variable b that is equal to the square root. A and b represent an even and odd number. It does not matter which is which, just that there is an even and an odd, so that they have no factors in common and cannot be simplified. We set up this equation as a over b equals the square root of 2. Now we square both sides so that it looks like a squared over b squared equals 2. Now multiply both sides by b squared so that our equation looks like a squared equals 2b squared. Since anything times 2 is an even number, 2b squared must be an even number. And since a squared is equal to 2b squared, it must be an even number too. Because a squared is even, it must be even. Because a is even, we can write the equation a equals 2k, where k represents another number. Then we plug 2k in for a in our previous equation so that we have 2k squared equals 2b squared. Then we simplify by squaring 2 and k. Our equation now looks like 4k squared equals 2b squared. Now let's divide each side by 2 to get 2k squared equals b2. This proves that b is even, not just 2b squared. A is even and b is even, thus contradicting what we said in the beginning. By both being even, they have factors in common and their fraction can be reduced. This is the opposite of all the things we said would be true if the square root of 2 was rational. Therefore, it is irrational. That's it for this video. Thank you so much for learning with me today. I hope you come back and learn some more. Please comment if you have any questions, like and subscribe to our channel, and I will be back soon with more videos.